talk about inequalities and one triangle today. You did have 4 theorems, and I think it's one of those things that once you explain them, they're pretty easy to understand, but whenever you're writing them down, they're kind of wordy. We're going to see that same thing tomorrow. So, there is a property in this section as well that I thought about having you guys copy down, but it's really pretty simple, so I didn't have you copy down, but it is in your notes. So it's the comparison property of equality. So it'll make more sense whenever I actually plug some numbers in, but it says if A equals B plus C. So I've got this number that's equal to 2 numbers added together, okay? As long as C is bigger than 0, okay, so you've got these 2 numbers, and on one side you're adding a positive number, okay? Well, if these 2 things are equal, A has to be bigger than B, okay? If this is equal to these 2 things added together, if one of those things is bigger than 0, the other 2 things, the first one has to be bigger than the second one. Okay, let's plug some numbers in, it'll make more sense. So if 10 equals 6 plus 4, if 10 equals 6 plus 4, as long as this 4 is a positive 4, 10 is always going to be greater than 6. It has to be, right? So if I have like 7 equals 4 plus anything, it doesn't matter. If that's a positive number, this is always going to be bigger than this number. It's just what it says, okay? If these 2 things are equal and these 2 things are being added together, that's going to be bigger than that one. Has to be, okay? Now, kind of tying that into one of your theorems is actually a corollary. If you remember what a corollary is from, I think, last chapter, maybe the chapter before, a corollary, it is a theorem, so it has equal value as a theorem. You can prove it, but how you prove a corollary is you prove it very, very easily using another theorem. So the theorem that you use for this corollary is theorem 312. So theorem 312 talks about the exterior angle of a triangle. So remember, the exterior angle of a triangle, if you take one of the sides of the triangle and just extend it out, that's the exterior angle. Theorem 312 said that this exterior angle is equal to those 2 added together. Every single time, okay? 1 is equal to 2 plus 3. So, kind of taking that into inequalities and kind of tying in that property that we just talked about, if we know that the exterior angle equals the sum of the 2, they were called remote interior angles, this angle has to be bigger than both of those. Tying in that property, right? If 1 is equal to 2 plus 3, 2 and 3 are positive, so 1 is going to be bigger than 3, and 1 is going to be bigger than 2. If 1 equals the sum of those 2 numbers, right? It's kind of like almost too obvious for it to make sense, okay? So that's what corollary to theorem 312 says, okay? Now these 2 theorems are going to be super useful when we talk about today. So theorem 510 says if 2 sides of the triangle are not congruent, okay, so they're different. It's not an isosceles triangle. It's not an equilateral triangle. So it's what they call a scalene triangle. All the sides are different, okay? So you have 2 sides of the triangle that are not congruent. The larger angle is going to lie opposite of the larger side, okay? So if I have angle Y and angle Z, if angle Y is bigger than angle Z, the side opposite of angle Y is going to be bigger, longer, than the side opposite of angle Z. Okay? So you're looking opposite of the angle. Okay? And theorem 511 just kind of says the opposite. It says that if 2 angles are not congruent, once again, it's not an isosceles triangle that has 2 congruent angles. It's not an equiangular triangle. Then the longer side lies opposite of the larger angle. So, if I know that BC is bigger than AC, this angle, angle A, is going to be bigger than angle B. Okay, so you can kind of order the sides from longest to shortest. You can do the same thing with the angles just by knowing the side lines. Okay, so let's talk first about using that corollary to theorem 312. So we've got this diagram here, got a couple triangles, some markings, angles. if I wanted to know why is the measure of angle 2, how do I know that that's greater than the measure of angle 3? So we're going to use the corollary to theorem 312 that says the exterior angle is greater than either one of the remote interior angles. Here's the problem with this diagram. Angle 3 is an interior angle of this triangle, but angle 2 is not the exterior angle. Remember, to create an exterior angle, you have to extend one of the sides. That would be the exterior angle, right? 2 and then that little gap right there. So 2 is not an exterior angle. Yeah?
1 is an exterior angle.
Okay. 1 is an exterior. See how I take this side and extend it out? 1 is an exterior angle. Great. Who cares? Go ahead.
They're both equal because triangle BDC is an isosceles.
Okay, see how these are marked? Okay. Angle BDC is an isosceles triangle. And I know that the measure of angle 1 equals the measure of angle 2. Because in the last chapter, we learned about the isosceles triangle theorem. And the isosceles triangle theorem says the angles opposite the congruent sides are also going to be congruent. Okay, well, if I know the measure of angle 1 equals the measure of angle 2, why does that tell me that angle 2 is greater than angle 3? How does that help tie all this together? Or I guess, what do I know about angle 1 and angle 3? Using theorem, corollary of theorem 312. Okay, so that's theorem 312. It says, yeah, angle 4 and angle 3 would equal the measure of angle 1, and then time that into the corollary. The measure of angle 1 is going to be bigger than the measure of angle 3, right? I know that the measure of angle 1 is going to be greater than the measure of angle 3 because of the corollary of theorem 312. It's kind of like a mini little proof here. And then kind of substituting all of this around, I know that the measure of angle 2 is going to be greater than the measure of angle 3. Just swap them around, right? So kind of using isosceles triangles and then that corollary there. Okay? One of the big things you're going to be doing today is using these two theorems up here, the theorem 510 and 511, to be able to tell which is the longest side in the triangle, which is the biggest angle, which is the smallest angle. So we have this triangle TUV. I know that angle U is 58. I know that angle V is 62. We want to order the sides from shortest to longest. Okay? So remember, these theorems up here say that the biggest angle is going to lie opposite the longest side. So kind of thinking of that the opposite way, the smallest angle is going to lie opposite of the shortest side. Then you're saying I only know 2 of the angles. If U is 58 and V is 62, probably going to find the measure of angle T. How would I do that? Good. So 58 plus 62 is 120. 180 minus 120. Angle T is going to be 60. Okay, so if I want to find, we want to go from shortest to longest. So if I want to find the shortest side, I need to start with the smallest angle, which is the smallest angle, U. So the shortest side is going to be the side opposite. It's going to be TV. Side TV is going to be the shortest. Okay, the next biggest angle after angle U will be angle T. So the side opposite of angle T is going to be UV. And then finally I have angle V is the biggest angle, which means the longest side is going to be side TU. That's a good chunk of what you're doing in your homework today. Pretty easy. Right? Okay. The other theorem that you guys copied down is the triangle inequality theorem. So this would have been a fun activity to kind of to start with if we had the time to do it, is if I gave you guys a bunch of different like spaghetti noodles, okay, of different lengths, and I asked you to make triangles out of these different sizes of spaghetti noodles with the understanding you can't break them, okay? And I go, well, that'd be easy, right? Just lay the spaghetti noodles together and form a triangle. Here's the thing, if I gave you a spaghetti noodle that was 10 inches long, and a spaghetti noodle that was 3 inches long, and another one that was just 1 inch long, so you've got like this 10 inch, and then 3 inches and 1 inches, the two smaller spaghetti noodles, they're not going to be long enough to meet in the middle there, okay? So it's not just like you can have any 3 side lengths for a triangle. It doesn't work that way, okay? There's kind of some criteria, and that's what the triangle inequality theorem says. Is actually, if you take any 2 sides of a triangle, any 2 sides, if you add them together, it has to be bigger than the third side. Just think about it. You've got the 2 inches and the 3 inches, or whatever I said it was. That, at longest, if they were flat, right, it'd only give you 5 inches. That's no way. No way is that going to give you 10 inches, right? If it's going to be even like the most flattest triangle you could possibly be, it's got to be bigger than 10 inches. Does that make sense? Okay? So what we can do is if I give you 3 side lengths of a triangle, like if I have lengths 4 yards, 6 yards, and 9 yards, to tell whether I would be able to make a triangle out of this, you just kind of have to check all 3 scenarios, okay? If I add 4 plus 6, this would have to be bigger than 9, right? This side and this side has to at least to be able to create bigger than that 9 side, okay? Well, is 4 plus 6 10 greater than 9? Okay, so that side works out. Now we have to check the other ones as well. So if I take, let's do 6 plus 9, that has to be greater than that other side, which is 4, right? Because I'd have to write the 6 and the 9. You'd have to at least be able to create that 4 down there, which would give you 15 is greater than 4. So that works as well. And so then finally it'd be, what, 4 plus 9 would have to be greater than 6, so 13 greater than 6. Yeah. So it works. You could add any 2 sides, and it would be greater than the third side, so yes. You would be able to create a triangle with those 3 side lengths. Okay, let's get this glued into your notebook. I know I'm a couple pages behind here. This is section 5-6. This is inequalities in one triangle. Okay, so what are you guys doing today? At least I think, really pretty simple. So first thing is using those 2 theorems to decide how you could order the angles or the sides from smallest to largest. So number 1, let's draw triangle QRS. We want to order these angles from smallest to largest. So let's say segment QR, side QR is 5.4, RS is 3.1, QS is 6.2. Okay, so if I want to list the angles from smallest to largest, the smallest angle is going to be opposite of the smallest side. What's the smallest side? RS. So the angle opposite of RS is Q. So angle Q is the smallest. The next smallest side would be what? QR. And the angle opposite of QR, angle S. So then the last angle would be angle R. Okay, now what if we ask a similar question, but I have triangle XYZ, where XY is 14, YZ is 8, and XZ is 16. Now, if you wanted to, you could totally draw triangle XYZ and just label the sides. Absolutely. But let's see if we do this without it. We we know which is the smallest side. What's the smallest side? YZ. Now, what I need to know is what angle is opposite YZ. X. How do you know X? I don't have a picture. It's the other angle, right? If this is YZ, that's Y, that's Z. The other angle? Yes. So the smallest angle is X. Without drawing a picture, I can tell you that. What's my next side? Side.
Oh, YZ.
XY.
Oh.
8 and then XY. So what angle is opposite of XY?
Z.
Angle Z. And then what's my last angle?
Y.
Angle Y. Okay, let's do the same thing, but let's do with the sides. So number 3, let's have triangle AJB. Angle AJB. Angle A is 33. And angle J is 64. So if I'm going to order the sides, I probably need to know what that other angle is. I'm going to find that measure of that other angle. 64 plus 33 gives me 97. Is angle B 97? No. It's 180 minus 97, which would give me 83. So if I want to start with the shortest side, I need to find the smallest angle. What is the smallest angle? Angle A. And the side opposite of A, JB. Okay. My next angle would be J. The side opposite of J, AB. And then my last side would be that JA. And then let's see if we can do the same thing but without a picture. So this time we have triangle AEB. If the measure of angle A equals 15, the measure of angle E equals 120, and the measure of angle B equals 45. So we can kind of do the same thing we did above, right? I know which is the smallest angle. What's the smallest angle? A. Okay, so the side opposite of A is going to be the side that includes those other 2 points. So what side is opposite of A? EB. Yeah. Side EB. Okay, my next smallest side angle is 45. So what side is opposite of angle B? AE. And then lastly would be side AB. Okay, that's a good chunk of your homework right there. Make sense? Okay, so then you're also going to be using that triangle inequality theorem, deciding, okay, if you have these 3 lengths, could they be the lengths of a triangle? So, number 5, let's say we have 8 feet, 10 feet, and 16 feet. Now remember what that triangle inequality theorem says. If you have these 2 sides that are 8 and 10, okay, if you add them together and take 8 plus 10, it would have to be greater than 16. Well, 8 plus 10 is 18. 18 greater than 16? Yeah. Yeah, you'd be able to make that. You'd be able to make that connection, right? Okay, and then if you take 10 plus 16, that would need to be greater than 8. So is 16 greater than 8?
Yeah.
So those 2 work. But you'd also have to take 8 plus 16. That'd have to be greater than 10. So 24 greater than 10. Yeah. Okay, so they all work, which means yes, I would be able to create a triangle out of this. Okay, and then let's say we have 7 inches, 11 inches, and 18 inches. If I can make a triangle out of this, I should be able to take 7 plus 11 and it should be greater than 18.
Nope.
It equals 18, right? It equals 18. I have 18. Is 18 greater than 18? No. It doesn't work because think about it. If you had a side that was 7 and a side that was 11, and you were trying to like stretch it out to make this third side 18, you'd have to lay them flat, right? 7 and 11 to get to that 18. And if it's flat, it's not a triangle. It's going to be a straight line. That's not going to work. Okay? The last thing you're going to be doing is kind of that same thing, but just maybe applying it in a different way. So instead of giving you 3 sides, I want to find, if I give you 2 sides, what could be the possibilities for that third side? So number 7, let's say we have 2 sides that are 6 centimeters and 9 centimeters. I want to find out what that third side is. Okay? Well, here's the thing. I know, and we're going to have to find kind of a range, so it could be from like this number to this number. Okay? I know that if I add these 2 together, if I take 6 plus 9, it has to be greater than that third side. Right? So, x, if I get 15 is greater than x, flip it around. That number has to be less than 15. Can't be bigger than 15. Okay? But I also know that if I take 6 plus that third side, it has to be greater than 9. Right? So, subtract 6 from both sides. Well, it's got to be bigger than 3. But I know, too, that if I take 9 plus that third side, okay, it's got to be greater than 6. So doing the same thing, I just don't know what that third side is, right? So subtract 9. I know that x would have to be bigger than 3. So kind of got 3 options, okay? X has got to be a little smaller than 15, greater than 3, and greater than negative 3. One of these is unnecessary. What between these two? They kind of overlap a little bit, right? If you want all the numbers bigger than 3 and bigger than negative 3, well, okay, here's the thing. If I throw out the negative 3, sorry, no, you're right, because it has to work for both. Yeah. Okay. I think I told the last class wrong. So this would be right, okay, because it has to work for both. It has to work for all of them. Okay. So these would have to be the numbers bigger than 3 and less than 15. Because if you tried to pick some of these numbers, they're not going to work, and it would have to. It'd be like an and inequality. Definitely till the second hour wrong. It'd have to be anyway. So bigger than 3, but less than 15. Okay. Do one more of those. If I have 24 kilometers and 30 kilometers. So doing the same thing. We've kind of got three things we've got to figure out. First of all, I know if I take 24 plus 30, it has to be bigger than that third side. 24 plus 30 is 54. It's got to be smaller than 54. That's the upper limit. Now for the lower limit, I know if I take 24 plus that third side, it's got to be bigger than 30. So x has got to be bigger than 6. And if I take 30 plus that third side, it's got to be bigger than 24. So x would have to be greater than negative 6. And you notice it's kind of the same thing that happened in the last one. Okay? Between these two, they overlap, right? They overlap starting at 6 and above. So we don't We need that negative 6. X has to be bigger than 6 and less than 54. So between 6 and 54.